Now, we've looked at transformations before, and we've done a little bit in terms of dilation, reflection, translation, just in terms of our teaching and what you're seeing in terms of graphs and things like that. But this is the first time we're actually looking at anything formal to do with transformations, and basically it looks something like what we've got here. Apologies for the planning. Ideally, this y equals f of x should be on the left, and then we should be pointing towards the right because we generally lead from left to right. So we're going to have to go a little bit in reverse here. So think if you've got a function y equals f of x, as well as there, and then it has these operations done to it. For example, a multiplies f, x has h subtracted from it, that's all multiplied by n, and that all has k added to it. Well, then this is the types of transformation that will happening. So, and I've got these graphs here to show you how it will all fit, hopefully. So basically, your A, depending on what that is, that's your dilation factor from the x-axis. Also, whether it's positive or negative determines its reflection. So if it's negative, it gets flipped in the x-axis. N, so a value of n here, is a dilation from y, but it's not just like A, so it's just whatever A is, it's 1 on n. So if this was a 2, it'd be 1 on 2. If it's a 3, it'd be 1 on 3. Also, its sign determines the reflection in the y-axis. And like I said, it's based on the sign of it as well. H is your horizontal translation, and K is your vertical translation. So H, how far left and right, and remember if it's negative, it goes to the right, if it's positive, it goes to the left, and our vertical translation is how far up and down it goes. Now, VCAR, or according to the study design, they want you to understand this in a certain way because of CAS. That's why we're keeping with this notation, because if it's not written in this notation, you want to make it so it's written in that notation. And so when you ask what kind of transformations are performed, you can have a look at what we've got here, and you can make it into what we've got there, and then from there you can answer whatever questions you have. But let's just have a look at how this works. So let's say we've got a base function of y equals x minus 2 all squared. Now we know that that looks like this. We're at 2, and we're cutting through there at 4. So that's that one there. Now, if I was to, so we change colours. Now, if I was to draw 2 of, if I had a value of 2, well, we've got a dilation of 2 from x. So that basically, your turning point is still the same, but all the other values become doubled. So where it crossed at 4, here it's going to cross at 8. So that's how that looks. Now, if we've got a 2 in front of the x, that's our value of n, like we've got there. Then what will end up happening, and I'll just get rid of that other graph, if I can do enough undos. There we go. So we're looking at 2x minus 2. What that is, that is a dilation in y, so it compresses horizontally. So basically, all the x values get halved, or they're reduced by a factor of 1 on 2. So where we've got an intercept there at 2, we're going to have an intercept, I'll change colours, we're going to have an intercept here at 1. So it's going to go something like that. Still going to cross at 4, but instead of having a turning point at 2, it's now got a turning point at 1. So that's what we're seeing there. Now, if, like it says here, we're going x minus 3, our value of k is 1. So it's going to be translated 1 to the right. So where we had a value there at 2, we're going to go through at 3, and everything else is the same. Except, all the values have been moved across at 1. Moved across to the right by 1. So where we had here of 0 and 4 now becomes, with this graph here, 1 and 4. So all the values have been shifted across to the right by 1. Just wondering if we've got enough there for an extra colour. I think I might have to remove some of these lights. And it'll be the most recent one. If it'll let me. Okay. So now we're looking at choose a different colour again. Now we're looking at x minus 2 plus 1. So this is our value of k. So k is a vertical translation, so it's going to move 1 unit up. So we're starting at 2, or we've started at 2, now we're with 2 and 0, now 2 and 1. So it's going to go like this. And what was it, 0 and 4 is now 0 and 5. So all of the values have increased by 1. Alright, now we're going to have a look at a reflection. So we're having a look at this one. So now whatever is in front of x, once again it's n, and if it's negative, well then it's going to reflect in the y-axis. So where we're at 2, we're going to go to negative 2. So here we are at negative 2, and then it's going to cut through like that. So still going through at 4, still got a y-intercept there at 4, but it's just changed how it looks. So it's been reflected in the y-axis, and that's because we've got a negative just in front of the x. Now that changes again when we've got the negative out front of the whole thing. What this does here, that's A, so that changes, that has a reflection in the x-axis. So everything's going to be the same except our values that were positive will now become negative, and the negative values become positive. So where we so 2 and x value of 2 for the turning point is still the same, but if we have a look now, it's cutting through at negative 4 as opposed to up here at positive 4. So that's a basic rundown of some transformations written in a general form like this. So A is your dilation and reflection from x, n is your 1 on n is your dilation from y and your reflection on the y-axis, h is your horizontal transformation, and k is your vertical transformations, or translations rather.